Hello everyone, myself Rumaysa yadwad and thank you so much for giving me this opportunity to speak at this competition. I am very much excited to share my idea with you and discuss on the topic touch DNA, revolutionary evidentiary DNA forensics. So let's start with the question, what is touch DNA? Many of us might be hearing this term for the first time. No worries, let me tell you. Touch DNA, also known as trace DNA, refers to the minute particles of DNA that are left behind on objects or surfaces when someone touches or handles them. These DNA samples come from skin cells that are shed naturally by a person's body. Even though the amount of DNA is very small, forensic experts can analyze it to identify individuals and link them to the crime scene. In the earlier days of forensic science, DNA analysis relied heavily on physical biological material such as blood, saliva, or hair. The technique was groundbreaking at the time. However, it had limitations. Investigators needed a significant amount of biological material to extract a reliable DNA profile. However, as the science evolved, so did our ability to detect and analyze even the smallest particle of genetic material. This led us to the birth of touch DNA. This method allowed investigators to extract DNA even from mere skin cells that are left behind by a person when they touch a surface. The development of polymerase chain reaction (PCR) allowed for the amplification of tiny amounts of DNA, making touch DNA analysis possible. The significance of touch DNA lies on its ability to provide investigators with crucial leads. For instance, in robbery cases where the perpetrator does not leave behind any fingerprints or any other biological material, a trace of touch DNA on doorknob or window is sufficient to provide them with essential leads and help them in further investigation. The collection of touch DNA requires a careful and meticulous approach to ensure its integrity. Firstly, investigators identify potential touch DNA sources such as surfaces, objects, or clothing. Next, investigators document the scene and the object to be corrected. They wear self-protective equipment to avoid contamination. They use cotton or nylon swabs to correct DNA. These swabs are often slightly moistened with distilled water or saline solution to help lift skin cells from the surface. In many cases, several swabs are used on different sections of the object to increase the chance of correcting the DNA. Each swab is used on one section to avoid contamination. After collection, experts air dry the swabs, store them in a sterile container, and label and document each swab. In lab, forensic experts extract DNA from each swab, amplify it using PCR, and analyze it using STR, short tandem repeats. For the victims of violence like sexual assault or murder, introduction to touch DNA is particularly invaluable and helps them identify perpetrators and bring them to justice. Touch DNA also provides closure to victims and their families. The touch DNA also provides peace of mind to the victims, knowing that the perpetrator has been identified and brought to justice. This also facilitates healing process to the victim by providing closure and accountability. Lastly, touch DNA contributes to improve safety in our communities, making it a better place for all of us. In conclusion, touch DNA is a revolutionary forensic tool that has transformed the way we investigate crimes, brought perpetrators to the justice. This also provides closure to victims and their family and exonerate the wrongly accused. Thank you.